Hi and welcome back to Module 6, Acid and Base Reactions, and today we're looking at video number 4, which is our acids plus our carbonates. Again, you would have seen these in Year 10 and in the Year 11 course, so this should be really just consolidating your current knowledge. So when an acid and a carbonate react, they produce a salt, carbon dioxide and water, and as we found in our last video, that when we have water as a product, we know that this also is a neutralization reaction, just a different form, but because that water is produced, it's still a neutralization type reaction. And again, we have a general equation here. So our acid plus our carbonate gives salt plus carbon dioxide and water. And one way we can test that carbon dioxide is actually formed, we'll see a bubbling and effervescence, but we can actually test it with lime water. And if we bubble that carbon dioxide produced into our lime water, it will turn a milky color. So this is a sort of diagram that you saw in the last video as well. Just again to refresh, how do we determine what the salt is that's formed? So acids produce certain salts. So if I've got hydrochloric acid, I know that I am going to produce a chloride salt. And so then we get the name of our metal, the name of our salt, or the metal for our salt, from our carbonate. So let's have a look at a couple of examples. So again, let's try this with an example. So we'll use some things that you're familiar with. 2HCl. Actually, I might get rid of that 2 initially. I'm giving away the answers. HCl, aqueous in solution, plus our sodium carbonate. So sodium carbonate, Na is 1 plus. Carbonate is CO3 2 minus, so we get a Na2CO3. And it is also, looking at our solubility rules, it's soluble in solution. And then we're going to form a salt. So our salt is going to come from the metal of our carbonate and the anion of our acid. So we did know or saw before that our hydrochloric acid forms chloride salts. So in this case, we are going to get NaCl again, and it's soluble in solution, so it's an aqueous form. We know that it produces water, and water is a liquid, and carbon dioxide, which is a gas. So again, using those solubility rules just to double check, but all our chlorides are soluble, and our group 1 metals are soluble, so it's handy to know that just your sodium chloride is soluble. Makes things a lot easier. Now let's have a look and balance these equations. We've got 2 hydrogens on this side, so we'll need to pop 2 over on this side. Over here we've got 2 sodiums, so we're going to need 2 sodiums there. That then brings us to having 2 chlorines, and we've got 2 on the other side, and we are now balanced. So let's go about writing the net ionic equation. So this HCl is soluble in solution, so we're going to have 2H plus 2Cl minus plus our 2Na plus and CO3 2 minus. Now it produces NaCl, which is soluble in solution, so it will form its ions, so it's a plus and a 2Cl minus. And we're going to produce here H2O liquid, and it'll stay in that form, and CO2 gas. Running out of room there. Make sure you try and make some space, unlike what I just did. And let's see what we can do now. We've got our chlorines on both sides that we can get rid of. We've got our sodiums on both sides that we can get rid of. And what we are left with now is our 2H plus and our CO3 2 minus, forming our H2O, which is a liquid, and our CO2 gas. So let's have a go at another example. So this time let's try nitric acid plus copper 2 carbonate. Again, I would suggest pausing the video just here to go and have a go and see how you go doing it independently, and then after you've done it, press play again and see how you go. So nitric acid, if you use your table again from the first video, HNO3, our copper 2 carbonate is just CuCO3, and it's insoluble in water, and we tend to just use it as a solid, and it's now going to form the metal from our carbonate and the anion from our acid, so it'll form a nitrate. So we've got NO3. NO3 has a valency of 1 minus. Copper in this case is 2, so we're going to have 2 lots of the nitrate there. Again, an acid plus a carbonate produces a salt. We've got the salt, and then we've got the carbon dioxide, which is a gas, and the water, which is a liquid. So you need to determine from your solubility rules here, again, all nitrates are soluble, so that is aqueous in solution. Now we're going to have a go at writing our ionic equation from this, or our net ionic equation. So we should check first of all that that equation is balanced. 2 nitrates on that side, so there will be 2 on that side. So now 2 hydrogens, 1 copper, and CO3. It's now balanced, so we get 2H plus 2NO3 minus. Now the copper carbonate will not separate into its ions because it's solid, so it will stay as it is. And this is aqueous, so it will form plus CO2 gas plus H2O liquid. So all we can really do in this one is get rid of our nitrates. In our net ionic equation will be aqueous. Forming copper ions. Sorry about that. And carbon dioxide gas and H2O liquid. So you can see that one's a little bit different to the other one and not always in that general form. And we'll discuss those a little bit more as we come across some things. Thanks for watching. See you next time.